Welcome to AI Evening News. Right now, you're renting your own intelligence. Every question you ask an AI, you're paying a stranger's computer to think for you, and that computer reads everything you send it, then bills you again next month. Here's the part nobody puts on the pricing page. The graphics card already sitting in your PC, a mid-range 60-class NVIDIA card, can run a real AI model, on its own, offline, for the price of the electricity. No subscription, nothing leaving your desk. So let's talk about how the cheap GPU quietly became the subscription killer. Let's just add it up. ChatGPT Plus is $20 a month. Claude Pro, another $20. Add one or two specialist tools, and you're past $100 before you've noticed. For a power user, that's $100 to $200 every single month, over $1,000 a year, and you own nothing at the end of it. You're paying rent on a brain you'll never keep. And that's just the flat subscriptions. The pay-as-you-go side is sneakier. Wire up an API for coding or agents, and the meter never stops. I've watched a single busy afternoon quietly burn through $40 in tokens. You don't feel it until the invoice shows up. Honestly though, the money is the polite part. The hidden costs are worse. Every prompt you send gets logged. Your data helps train the next model you'll have to pay for. And when the servers are slammed, you get throttled, usually right when you're in the middle of something. A local model turns that whole deal upside down. You buy the card once. After that, every answer is free, private, and yours. That's the real shift here. You stop renting intelligence. You start owning it. So why the 60-class card specifically? Why not the 4-figure flagship everyone films on YouTube? It comes down to one number, VRAM. That's the memory on the card itself. A modern 60-class card gives you somewhere around 8 to 16 gigs, and that turns out to be the Goldilocks zone. Now, here's the trick that makes it possible. It's called quantization. Normally, a model stores every number in 16 bits. Quantization crushes that down to 4 bits, sometimes even 2. That's roughly a 4x cut in memory. A genuinely capable 8 billion parameter model goes from around 16 gigs down to about 5. Just like that, it fits on a card you can actually afford. Now, quantization isn't magic. Squeeze too hard down to 2-bit, and the model gets noticeably dumber, like it's a little tired. And not everything fits. A 70 billion monster or a huge context window still wants a bigger card. But 4-bit on a solid 8B model keeps almost all the smarts and lands right inside your 8 gigs. That's why it's the sweet spot, not a compromise. And because the model lives right there on your GPU, there's no trip to a data center, no network in the way. The answer starts the instant you hit enter. No waiting in a queue 3 time zones away. Hardware people wrote off as budget, doing the job everyone assumed needed the cloud. Now, a couple years back, running a model at home meant compiling C++ and fighting CUDA drivers at 1 in the morning. I've been there. It was miserable. That's over. The tooling caught up, and getting started is almost boring now, in the best possible way. Ollama runs a model from a single line in your terminal. LM Studio is a clean desktop app with a download button. Jan looks just like the chat app you already use all day. Here's what it actually feels like. You type one line, Ollama run, then a model name, and hit enter. First time, it grabs the model. A few gigs, 1 download. Then you just talk to it. You ask a question, and the answer streams back while your own fan spins up. No login, no meter ticking. Just your machine, thinking. From that moment on, your GPU does the work, not somebody's API and not somebody's invoice. The model's a file on your drive now. It's yours. And the open models got good. Llama, Mistral, Qwen, Gemma. Free weights, downloaded millions of times, running on hardware just like yours tonight. If that monthly bill is starting to look a little silly to you, good. That's the point. The best part still coming. Here's the part that matters most to me. When the model runs on your machine, your data never leaves your machine. You can pull the network cable out of the wall and keep working. Your notes, your code, your half-finished ideas, none of it gets shipped off to a server you don't control. Compare that to the cloud. Providers go down, and when they do, half of tech Twitter finds out at the exact same minute. They swap models out quietly. The thing that worked great last month gets slower or more restrictive, and you find out the hard way mid-task. Local has none of that drama. No rate limits, no surprise refusal on a perfectly normal request, no, you've hit your cap, try again later. It just runs. You're the one in control of the model, instead of the model's owner being in control of you. Private, predictable, and there whether you're online or not. Okay, say you're sold. How do you actually start? It really comes down to matching the model to your card's VRAM. Quick guide. 8 gigs comfortably runs a sharp 7 or 8B model in 4-bit. That's the friendliest on-ramp, something like Ollama or Quen. 12 to 16 gigs opens up the bigger 13B models and cleaner quantization. Past that, you're playing in the big leagues. And the trend is quietly on your side. Open models keep getting smaller and smarter at the same time. Today's 8B model can hang with the giants from 2 years ago. Your card gets more capable while you sleep. Same silicon, better software. So the math is almost too simple. A 60-class card pays for itself against the cloud in well under a year. After that, you're running real AI for the cost of running a light bulb. That's the local first shift in one line. Intelligence you own on hardware you already have with data that never leaves the room. If you're already running a local model on a 60-class card, tell me which one you landed on. I genuinely want to know. And if you want the full setup, start to finish, that's the next video.